Here we continue looking at multiple integration. We have the graph of y equals x squared. The question here, find the area enclosed by the x-axis, is this, the line x equals 1, and the curve y equals x squared. Alright? So that area would be this area here that I'm shading, right? That's the area that we need to find. Now, what we do is look at stacking up squares upwards from the x-axis up to the curve. Now these squares are of height delta y and width delta x. Now when we stack them upwards like this, vertically, what we're adding up, finding the sum of, are delta y. Then what we're going to do is consider what it is we're adding up from where to where. Well, we're adding up from 0. We're adding up from y equals 0 up to y equals x squared. That's where we're adding up, right? So you can see that the ceiling is not a fixed number. At this point, we would move from here up to the curve, and the height would change as we go along. Alright? So that's what we have there. Now, alright, let me just check on something here. Okay, good. Now, when we do this and we finish each point going from the floor up to the ceiling, then we have to start moving to the right, right? Stacking these things from left to right. So we're going this way. So we are summing, we're adding up things where x is changing. So it's delta x. All of these represent each column going upwards. But then we have to stack them from left to right. Where do we start and where do we end? Well, we start at 0 and we end at 1. So we're going from 0, so from x equals 0 to x equals 1. Alright? Now, as delta x tends to 0 and delta y tends to 0, then the summation symbols will change to integration symbols. We're integrating from x equals 0 to x equals 1, and of that we're integrating from y equals 0 to y equals x squared, and the delta will become dy dx, and we're integrating 1. So let's see how this will work out. We integrate from x equals 0 to x equals 1. Now what is it we're integrating? It's this part in the middle here. We're integrating that part. So when we integrate 1 with respect to y, we get y. And it's a definite integration, so we're going from 0 to x squared and then dx. Now here, this is equal to, it's the integral from x equals 0 to x equals 1 of, this is going to be at the upper boundary x squared minus the lower boundary 0 dx. And then we have the integral from x equals 0 to x equals 1 of x squared dx. This would have looked like what we did before when we use a single integration. But using a single integration like this is really the second part of a double integration. Alright? To find area, you use double integration. But what we had done before was to ignore the first part of it and just go to the second part directly. Now, this is the second part of the integration. We're going from x equals 0 to x equals 1. Alright, so when we integrate from x equals 0 to x equals 1 of x squared dx, what we have is x cubed over 3 from 0 to 1. So when we put in the boundaries, you get 1 cube over 3 minus 0 cube over 3. So this is 1/3 square units. So we have 1/3 square units here. So the area, let me just write it down, area equals 1/3 square units. So quick revision, we're integrating from 0 up to x squared of dy, and then across from x equals 0 to 1 dx. So this is x from x squared 0. So we're integrating from x equals 0 to x equals 1 of x squared dx. That will give us x cubed over 3 equals 1 cube over 3 minus 0 cube over 3, which is 1/3. Now let's look at it from another angle. Let's erase what we have here and look at this thing from another angle. Oh, I erased part of my line. Let me put back the line. Good. Let me just erase some of the working that I have here. Now, at first we had stacked up the squares vertically and then move them horizontally. Suppose now you're required to put the squares together horizontally first. Then the thing is, what you would be adding up goes in the direction of x, so it's something dx. Right? You're adding up something from where to where. Now remember, you'll be starting from the curve towards this line to 1. So you're reaching to x equals 1. But where do you start? It is going to be x equals something. Alright. Notice we have y equals x squared. To say x equal, what we do is transpose this formula, this equation. So get, if y equals x squared, then x would be, well, if y equals x squared, x would be the square root of y, which is y to the half, right? So x equals y to the half, or the square root of y. X equals square root of y. Okay? And then these little squares, these shapes that we have to put one on top of the other now in order to stack them from the floor to the ceiling. So we would be going upwards this time. And in that case, we would be adding up something. Alright, let's put the addition summation sign here, because this is what we're going to be adding up. This represents the vertical lines of squares, and we're adding them up. We're adding and changing y. So, it's delta. I'm using the summation sign, so I'll use delta. This one is delta y, but where we're going, from where to where? It will be from 0 to, well, y goes up to 1, right? From 0. So y equals 0 to y equals 1. Now, as delta x tends to 0 and delta y tends to 0, what we have is the integral from y equals 0 to y equals 1 of the integral from x equals square root of y to x equals 1 of dx dy. Alright? Now, this is really 1 you're integrating, and when you integrate 1 with respect to x, what you get is x. And it's a definite integration, so we're going from x equals square root of y up to x equals 1, and then we will soon do this integration from y equals 0 to y equals 1 dy. Alright? Now put in the boundaries. We're going 1 minus the square root of y. I'm going to integrate that from y equals 0 to y equals 1 dy. Now, this is going to be, alright, let me rewrite it. We're integrating from y equals 0 to y equals 1, 1 minus y to the half dy. Because we're looking at y raised to the power of a half and using the power rule. So this becomes y minus y to the half plus 1 over half plus 1 using the power rule from 0 to 1. Alright? So half plus 1 is what? 1.5 is 2 and 3 over 2. So it is y minus. So 1.5. 1 plus half. 1.5 is 3 over 2. So it's y to the 3 halves over 3 halves. 3 over 2. Because I say half, I put half down there. From 0 to 1. Now, here we have 1 minus 1 to the 3 over 2 over 3 over 2 minus 0 minus 0 to the 3 over 2 over 3 over 2. You know that this part here will go to 0, right? 1 to anything is 1. So it's 1 minus 1 over 3 halves, which is the same as 1 minus 2 thirds. Now 1 minus 2 thirds is the same as 3 thirds minus 2 thirds gives us 1 third. Square units, right? So, right, same 1 third square units. So as you see, when we integrate and switch around the dx and the dy, we have to also change up the boundaries, right? When you are stacking up upwards, you're going from y equals 0 to y equals x cubed, x squared, and then x equals 0 to 1. But when you're going this way, you're going from x equals something to x equals 1. So you have to transpose the equation to say x equals square root of y, and then you go from y equals 0 to 1. Alright? So I'll see you in the next video.